Hi, and welcome to Maths Appeal. I'm Bobby Seagull.
And I'm Susan Okereke.
And we are two maths teachers who absolutely love our subject of maths. And we're on a mission to try and show people actually it's a pretty cool subject.
And our aim as Maths Appeal is to show that everyone can do it. Maths sometimes has a rep for being difficult and irrelevant. And we want to make sure that everyone understands that you can have a go. Even if you think you can't, you can. That's our mission. This series is actually focusing on problem solving and mathematical thinking. And it's about trying to get you using maths in an applied way. It's not just learning some stuff, it's how do we actually use maths to solve problems.
And I think one of the things we've realised as teachers is that sometimes it's actually a tricky topic to teach, problem solving. So actually the best way is to actually go about doing some problem solving.
Yeah, let's do some problems.
And I think we're going to show it's like a fun thing to do together. A fun thing to do. That's what we always want to show you. It's not, maths is not just a solo activity. It's something that we do as a unit. But also, we want your interaction. Obviously, we love interacting with each other and our producer. But if there's any specific skills that you want to learn, do tweet us at Maths Appeal. If there's any subjects or problems that you want us to cover.
And every episode, we feature a maths problem and we go through some questions to kind of set up how we go about doing the maths problems.
Yeah, so the structure now, hopefully you've got embedded, but it's about thinking before the problem is firstly, how do you feel, the emotional reaction when you see the problem? And then secondly, thinking, does it actually make sense? Does it mean something to you? And I guess that's related to, do you have any questions that you might ask a teacher in theory about the problem? And then thirdly, thinking, what are the topics maybe in the syllabus that are covered in this question?
And so once you've set yourself up and your mind is ready to attempt the problem, the questions you then ask yourself, or we ask each other, are what facts do we know about the problem or from the problem? What rules, what formula are needed to work out this question? What facts can we derive from this problem, in the problem, and can we answer the problem now? So once you've gone through those questions,
definitely. Hopefully now you've got that system in your mind. We hope.
And we're hoping as well to go through in a bit more detail in today's episode. We're going to talk to you about why we think these questions are important to go through when you start a problem. So, Bobby, are you ready to tackle today's problem?
Definitely.
Brilliant. So we might even have our producer, Jenny, jumping on, so you might hear an extra voice. Grab a pen, grab a paper, get your heads ready for a maths question, and we'll get into it after this.
So our problem for today's episode is taken from a GCSE paper. So here it goes. So make sure you get your pen and paper ready. So a shop sells washing powder in 650-gram packs. And Susan has no washing powder. So she estimates that she does 2 washes a week, using 40 grams each wash. And Susan wants to buy enough washing powder for 13 weeks. So how many packs of washing powder does Susan need to buy? And I'll repeat that one more time. So a shop sells washing powder in 650-gram packs. Susan has no washing powder. And she estimates that she does 2 washes a week, using 40 grams each wash. Susan wants to buy enough washing powder for 13 weeks. How many packs of washing powder does Susan need to buy?
Right, so we'll tackle that problem in a moment. But while you're thinking about it and getting your head around it, we want to talk about expert versus novice problem solvers. And this is why we've set up the questions for doing this podcast. One of the reasons we've kind of decided to focus on problem solving and mathematical thinking in this series is we know that it's an issue for so many people. And also as maths teachers, we're obviously trying to get more people to become problem solvers. That's like one of our raison d'etres. That's why we're here. But we also know that it's challenging. And I think I sort of delivered a session for the NCTM. So that's the National
Centre for Excellence?
Centre for Excellence in Mathematical Teaching. And we've run this project on mathematical thinking. And it was really interesting to kind of be involved in trying to help teachers pull out ways to get their students to effectively apply the maths that they're teaching. So I think a lot of people think of maths, what's the topic? Here's an example, here's how you do it, go. But actually the real beauty of this subject is being able to use those skills and concepts to solve problems and to problems that are like non-uniform, so ones that look a bit random, but there's a lot that goes into that. And I don't know, have you read much of Craig Barton, Bobby?
So to be honest, I know we're not allowed to mention other podcasts, but I do occasionally listen to other mouse podcasts. That shall not be named, but no.
Well, why should I think we should? I think we're sharing here. It's all about
Yes,
sharing is caring.
It's a brilliant podcast. He does very like in-depth, deep dive. Sometimes if I've got like I'm doing like an hour, 2 hours worth of laundry and ironing, I generally put on Mr. Barton's podcast, have a listen. He has these really, again, deep dive conversations, and he's published
mainly
a few
for
books.
maths teachers. It's more specific. Ours is more general for anyone who wants to kind of get involved in like problem solving. But his is kind of specifically for maths teachers, and he goes into like the theory around learning and stuff like that.
So in fact, in our staff room, we have Craig Barton's books. We've got at least 2 or 3 of them. So definitely, if you're a maths teacher out there and want to learn more about pedagogy, and in fact, our discussion today about experts versus novice, Mr. Barton's someone that has spent a lot of time thinking about this, hasn't he?
Yeah, so there's the book I'm referring to is called How I Wish I'd Taught Maths. So he's kind of done quite an interesting setup. And with it, he talks about expert versus novice learners. And this is something I'd never really thought about. I understood there were challenges as a teacher in how do you deliver stuff to people who don't understand stuff that you fully understand, which is quite interesting. Mm-hmm. And he referred to something which I think all people should be aware of, and that's the curse of knowledge. So that's when you know something, it is super difficult for you to think and to understand and see this perspective of somebody who doesn't know that thing. And that's quite massive if you're a teacher, because like most teachers have been trained quite highly in their subject, and so there's loads of things you take for granted as you're delivering your information, that loads of the people that you're delivering them to just don't have those basics in them. And that's something to try and remember, which I think is quite a big thing.
Yeah, it's almost like I'm trying to think examples from the real world. Like one could be football. Anyone that follows football is like, offside rule's obvious, but if you don't know the offside rule, like it just makes no sense. Or if you're driving in one country and suddenly you drive on another side of the road, you're having to like, which side of the road, which way do I look? So it's all those things that you take for granted, actually you need to learn not to take for granted if you're an educator.
Well, and that's it. And I think there's it's that whole idea as well of like automatic versus deliberate. So if you're like driving a car and if you've driven for ages, you're not thinking about indicating or, speeding up or slowing down. You're just automatically doing that. But when you're a new driver, you're thinking about, I've not looked in the mirror yet. I need to look at the mirror now. I'm about to indicate what am I going to do next. So it's just that idea of like, understanding that difference. And so one of the reasons I wanted to introduce the idea of these problem solving prompt questions, which is kind of what we're doing in the podcast, is because in the mathematical thinking project that I delivered, it was really interesting. It talked about the idea of expert problem solvers and what do we do. So especially, let's think about specifically expert mathematics problem solvers. Bobby and I, as maths teachers, we've seen loads and loads of GCSE maths questions or A-level maths questions where we're like, we know how to start. So what we generally do, and this is from the project information, is we read the problem, then we ask ourselves questions automatically. Yeah. Then we look for key features in the problem. So if we're looking at see like a right angle triangle, we're like, that might be Pythagoras, that might be trigonometry. And we're automatically doing that without even like thinking. And then we start to look at indicators. So what in the question, what information are we given, and how can we use that? Again,
we don't really think about those steps, do we? We just do it like because of years of experience.
And that's something that we're wanting to encourage in this, because what was interesting, we did the training, was thinking about what do new problem solvers do. They generally look at a problem, then they stare at the problem, and then they stare at the problem some more because they don't know, because they're like,
such a good
I don't know. I stare and I still don't see what I meant to see.
Oh, you're actually describing some about my students occasionally.
Yeah, I mean, I've taught for many years, and that whole like, you're looking... You're looking and you're seeing nothing. Yeah. So the aim is to try and the idea of encouraging asking good questions internally. And that's what the prompt questions we mentioned earlier, that's where they're from. So this idea that the key to being a good problem solver is actually asking good questions, and giving prompts can allow people who maybe think of themselves as novices, or even who are just novices, a way in. And the key is a first start. So, and it's identifying, so it's trying to encourage people to identify the information that they can use immediately, the information that they will need to find, and then the math skills that they'll need to use to work out the question. But I wanted to add in the idea of emotions, because I think we sometimes forget that in maths that there's a lot of baggage.
It's probably more than most subjects. Like if people are doing history or languages or music, they don't really feel that same anxiety. With maths, you give them a problem, unseen problem. A lot of people feel, that fear.
I think it's interesting. I do think there is an element of fear with some things. Like if if someone said to me, like Susan Abseil or whatever, I'm like, that's a bit extreme, maybe. I mean, oh my god. Or like Susan, like, can you do like a watercolor painting? I'd be like, oh, I don't know if I can, but I could give it a go. And there's a little bit of an element of like, I'm not really arty, but I'm quite arty, but not, overly arty. But I think with math, it's quite loaded. And I think that's something that to be kind of aware of. That's why we're here, isn't it, Bobby?
So today, are we going to test our system?
Well, I think we're going to put it into practice. But I thought it would be really just good for people to know where these questions have come from. And it's the whole how we start and how we kind of then move on. So there's the pre-questions, and then there's the let's do some maths questions.
On that note, shall we do some maths questions?
Let's do some maths questions. Come on, yes. So tell us, what was the problem, Bobby?
A shop sells washing powder in 650-gram packs, and Susan's got no washing powder. So she estimates that she does 2 washes a week using 40 grams each wash. Susan wants to buy enough washing powder for 13 weeks. How many packs of washing powder does Susan need to buy? So,
going to the prompt questions. What did you feel when you first heard the problem? And how did you feel, Bobby?
To be honest, I quite like these questions because it's very much based on... This feels like it's a very numeracy, arithmetic number problem. Yeah. Numbers always been my thing in maths. Like I love maths because of number. If you gave me a geometry problem or something in shape and space, I'd be like, I need a bit more. But this one feels like it's in my street.
So you're kind of happy about it.
Yeah.
Jenny, can I ask you how you felt looking at the problem?
Yeah, I'm not very patient. So I just wanted to like grab the pen and just get stuck in, and then I would like try it first, panic later. That's probably my way of doing it, which is probably not the most methodical or sensible way of doing it. So yeah, that was how I felt. Impatient.
That's real. That's the emotion. You kind of jumping in, wanting to get involved, but then also know that you might have to sort of shift it. Okay, that's good. You didn't want to run for the hills. That's the key thing. Not quite.
But I think I've got this weird confidence, which I don't think is founded, because I think I've done it wrong. But like, I've definitely got this swagger. Like, yeah, I've got this. I don't have it.
That's good. At least it's not. At least it's not being petrified.
No, but I do. I suppose it's like waiting to be caught out is maybe that thing.
Yes.
I'm like, so on the surface thinking, yeah, and actually then when it comes down to it, I think I've probably not got it right.
Well, we've got to love this bravado. Let's get in, stuck in, and then see what happens. But as a teacher, I'd rather that than not do it, if I'm honest. So a bit of bravado, I think, is a positive thing. So let's see the next bit. Does the problem make sense to you? I mean, my question was why 13 weeks, but that's irrelevant, I guess.
Oh, it's a quarter of the year. It's like one season. Maybe like it's all your maybe it's like your summer clothes. You're like, okay.
Okay. Suddenly, Bobby, I'm glad I asked that question. 13 weeks is actually quite relevant, and now I know why I was thinking like that.
Yes, that's why you were thinking. There you
okay, and then the maths topics. So, what maths topics are in here? So, before we do any maths, what maths topics are in this?
So actually, I want to throw out to Jenny. Like, when you see from your school days, are there any topics in particular it screams out?
No. No. Like, I wouldn't know how to define this as a sort of type of maths.
Oh, but do you know what's great about that? Because as a maths teacher, we're thinking, that is weight, You know, it's like kind of thinking about kind of capacity, just generally just
Weights
weight.
and measures, yeah.
Weight and weights measures, also time, because weeks, trying to work out the sort of different types of like time, and then proportion as well, like how many things fit into something. So that's where that would kind of fit in. So that's where the maths would be, the maths specific to school, I guess, would be. I've not forgotten anything, have I, Bobby?
No, I think that's spot
Yeah.
on. I guess now this is the question that we all want to know. It's like, so Jenny, how did you get on with the problem?
Apart from wondering about Susan's like forward planning and hygiene,
Me too, actually, Jenny, me too.
I think I started off by thinking, okay, 2 washes a week using 40 grams each wash. So I just made it right. Well, that's 80 grams per week, 80 times 13, because she's wanting to buy enough for 13 weeks. So that's 1,040. And then I just divided 1,040 by 650, which gave me 1.6 packs. And now I'm just thinking, what have I missed?
Well, that's exactly how I did it.
Oh,
But then,
okay,
but yeah, that's exactly how I did it. But then, how many packs then would I buy?
2.
2, yeah. And why did you? And the question I also want to ask is, why did you divide 1,040 by 650?
Because 1,040 grams is what Susan, what you need for 13 weeks. And so it's, if you can only get them in a quantity of 650, it was how many quantities of 650 fits into 1,040.
That's the badger. So it's the idea of 650. How many 650s fit into 1,040, and that's why you've divided. I think for me, with regards to kids, a lot of them have an issue with that part and understanding how to like. It's how many things fit into it. But how do you feel, Jenny?
To be honest, completely triumphant, because the other problems you've asked so far, I've had no idea about. So I'm just grateful, basically blessed. That's how I feel right now. Blessed.
Today was the day. So today was the day, and you didn't even pick it. You didn't even say I wanted this question.
No,
so today was the day.
But it's definitely like for the other ones so far, I've gone down one route and not been able to get any further, and it's been, and then I've realized when you guys have worked it out that I just went down the wrong route in the first place. But yeah, no, it was triumph and happiness.
Round of applause.
Bobby, did you do it any differently?
No, pretty much the same way. Although when I've tried similar problems with students, they end up just like, they just pick random numbers to multiply and divide. It's like 650 times it by 2 divided by, it wasn't like they're just plucking numbers out. The good thing I liked about your approach, Jenny, is you were sort of almost like applying your practical real life mindset rather than like, obviously as maths teachers we want like a mathematical framework, but you were thinking, I can almost hear you thinking, if this is a real life situation, what would Susan do? And that's what got you through the situation, like applying maths to real life.
No, but
that's
you're
the
right.
aim.
Because that's if it's a really abstract concept, you're just like, well, why does this matter? But now, Susan's got to wash, guys. She's got to wash her clothes.
For a quarter of a year, tick. That's really quite great. Okay, well, Jenny, I'm glad of this. We look forward to potentially hearing your musings in the future, but we'll put that to one side for now. But well done and enjoy your triumph. So, well, we've shared our solutions. We will be putting those on Instagram and Twitter, and we have now got time for our maths fact.
Yes, it's going to be related to weights and measures. So actually, so what's the standard unit for a weight? Or a mass?
Like grams?
Yeah, grams, kilograms. So yeah, the gram, the kilogram. So from
We're talking metric though, aren't we here, Bobby?
Yes,
right?
we are talking metric. Oh yeah, I like this. Yeah, I like this. This is when maths teachers, you can't trick them. So for actually a kilogram is 1,000 grams. From 1879 to 2018, it's nearly a century and a half. There was actually a physical object in France known as the IPK. It sounds like something from the Avengers. It's called the International Prototype of the Kilogram.
Oh, wow.
And this is the kilogram. And in France, they call it Le Grand K. Le Grand K.
Le
and
Grand
it's
K.
it's like a platinum iridium cylinder. And only a few people have ever seen Le Grand K. And it's like hidden under like lots of bell jars and a triple lock vault. And this was like for the best part of a century and a half, the kilogram. But in 2018, the powers that be decided they're going to redefine a kilogram. Because a lot of things that they think like the meter, etc., they're actually measured using universal constants like the speed of light, etc. So they redefined a kilogram in terms of electric current. So it means that wherever you measure it in the universe, it's the same.
Sorry, what are you talking about? That's
goodbye.
incredible.
Yeah, I know. So goodbye to the Le Grand Quai.
So there's no longer a physical thing that's a kilogram. It's
No.
now electric current.
Measured in terms of that, which means in theory, you go to Mars or Jupiter or another galaxy, they could still recreate the same kilogram by an electricity experiment.
Wow, you've blown my mind on so many levels. I didn't know about Le Grand Quai. And now it's electric current. So does that mean that it's not affected by gravity? Is that the point? Or have I lost? Is that...
Some bits there's a gravitational constant.
Okay, of course. And that'll be... If you go to different planets, they'll shift that? Is that
Although the constant is different to gravity. Gravity is impacted by the mass of the body. So how bigger it is, the bigger the gravity. But the constant is the same, in theory.
Right, okay.
As far as we know.
Always a pleasure, and thank you for the facts.
And if you want to send us any maths facts, cool facts, or any calculations, or any problems even, just do get in touch. We're, as usual, at Maths Appeal on Twitter and Instagram.
And we're also on the special email. Heard about email? And you can email us on mathsappeal1@gmail.com.
So thank you so much for listening to Maths Appeal. And what would make a really big difference is if you give us a 5-star rating or spread the word, maybe tell some friends.
Thank you so much. We want you to be getting involved in doing some maths in your own time, please. And I hope you've enjoyed the music that was composed by Kelly Okereke, the image designed by Calix Davis, and the wonderful producer Jennifer Nelson. And we'll see you in episode 4 for more maths problems solved together and special guest Tom Crawford.